Okay, Assalamualaikum. Okay, guys, can you hear me?
Yes, teacher.
Yes, teacher.
Okay, all right.
Yes,
So,
teacher.
how are you guys? Okay, so it's already 3 p.m. Okay, so we have 33 students now. Okay. All right, 35 students now is okay. We just wait for your friend, huh? Okay. All right. So before we start, okay. So everyone, please ready with your textbook. Okay. And then the task that I give you just now. Okay. And also your flip notes. Okay. All right, guys. Okay. All right, guys. And one thing. Okay, I want you to have maybe a glass of water next to you. Okay. So please take now. Okay.
Okay.
Okay. We have 40 students now. Okay, guys, are you there?
Yes, teacher.
Okay, all right. So please ready yourself. Okay. Okay, we have 43 students now. Okay, maybe 2 minutes more. Huh? Okay, guys. All right. Okay, guys, maybe we have the class point for today. Okay, a bit on your mood check first. Okay. All right, one more minute. Okay. Wait, I'm not sending the code yet. All right, so guys, so we have 48. Okay, maybe two more students. Okay, we wait for another two students, please. Okay. Okay. Yes, we are here. Okay, we are GM and also YouTube. Okay. Okay, so we have here your friend here. Okay, Yuayin say hi. Hi Yuayin. Okay, Tashwin, Tashayani. And hi everyone. Okay, so we have 48. It's okay lah. All right, so guys, all right, so 49. Okay, so it's okay. So are you guys ready for the class point first?
Yes, teacher.
All right, so now
Yes, teacher.
I will share
Yes,
this.
teacher.
Okay. Okay, so guys, the code is 28430. Okay, we have 40 students now. 14. Okay. You may just use your smiley also. Yeah. Cool. Yeah. Excited. All right. Very good. Okay, 18 students with us now. We have some more sevens. They join us. Class point now. Thank you. What is gray area? What is that? Oh my gosh, what is that? Great, yes. Okay, 90 students now. Okay, 19 students now. 17. class points code is 28430. Let's go. I love class point, me too. Okay. All right, 4 students may join us now. Okay, 2 more. Okay, 1 more. Okay, it's already, okay, already 25 students now. Okay, but then, okay, 5 more students. Okay, we wait for your friend to answer the question first, right? Okay. Okay. All right, so who's crying there? Let's go, class point. Okay, another 3 students, please. Quite excited. Oh, okay. Okay, another 3 students, please answer the question. Feeling very, very good. It's a good time. All right. Okay, another 2 students, please. Okay. Pending 3 students. Siva, Praveen, and Shushindran. Okay, we wait for your friend first. Okay, 1 more student, please. Okay, 1 more. 1 submission. There we done. Okay, it's okay lah. Right. Okay, I think it's already 25 now. Okay. All right. So I close the submission now. All right. Okay. So insert. All right. Okay, guys. So very good. Okay, feeling very, very good. I'm happy. I'm really okay. Happy, excited. Teacher, I'm happy. Very good. I'm feeling just fine. Teacher, thanks for asking. Yeah. Okay, because it's today is Sunday, right? Okay, all right. So I know our moods is a bit on up and down. Okay, all right. But then we have only a week for PDPR, right? Then we have what, guys? Anyone?
Exam.
Holiday.
Exam. Oh, holiday for a week. Okay. Right. Okay, it's okay. All right, so we stop. Okay, I will stop sharing now. Okay, just class. All right, so without further ado, so let's continue with our lesson. Guys, am I still sharing the screen now?
No. No, teacher.
No, teacher.
No. The class point?
No, teacher.
No.
No.
Oh. Oh, the class point also, I didn't share the screen.
Yes, teacher.
No lah.
Yes, teacher. Yes, teacher.
So there is no sound there just now. No.
Sound good.
Sounds good. Oh, okay. It's okay lah. All right. So your friend submission you can see lah. Can see or not just now?
No, teacher.
No, teacher.
Oh, okay.
No.
All right. Okay. Okay. I'm not sharing the screen. Cannot see. All right. But then I think I'm sharing the screen like just now. Let's check. Okay. All right. So can see or not now? Your friend's submission. Can see or not?
Can.
Teacher.
Okay. So this all.
Yes, teacher.
Okay. Your Okay. But then I can read this one. What is this? In Japanese here. Anyone? One UUM and one UTP. Please help me. What is that? The down below one. Guys, what is that? Oh, Korean. Oh, yeah lah, it's Korean. I don't know also. Whose one? Okay. All right. Oh, okay. It's okay. All right. So this all okay for the class points. So we have done. Okay. So just continue. Let's continue with our lesson today. All right. So please take out your textbook now. Okay, everyone with your textbook now. Okay. All right. Eat. And also your flip notes. Okay. All right. So wait for a while. Close this one first. Save. Okay. Right back here. Okay. Wait now.
I don't speak Korean.
Sorry. Can see or not, guys?
Can, teacher.
Can.
teacher.
Okay, very good. Okay. All right. Okay, this is our chapter 4. Okay, chapter 5 now. Okay, this one. Okay, all right. So ready, guys? Are you ready, guys?
Ready, teacher.
Yes,
Okay,
teacher.
so
Yes, teacher.
yes, okay, we have done with okay.
Yes,
Anyone
teacher.
please tell me what we have discussed on last Thursday? Anyone?
Particles.
Diffusion. Yes, okay, about diffusion. So, guys, we have done with the diffusion. Okay, so all of this, okay, you understand. So, for solid, liquid, and gas, so the diffusion happen faster in which states of matter, guys?
Gas.
Gas state, very good. Okay, so now let's discuss about this one. Okay, this one, can see or not the slide, guys?
Yes, teacher.
Okay, it's about more about
Can.
chemistry. Okay, this is chemistry lah. Okay, so guys, changes. Okay, changes. The word changes. Oh, sorry. The word changes in the states of matter. Okay, so we need to understand that changes that involve the states of matter. So we need to analyze states of matter. We have how many, guys?
3.
Okay, three, right? Okay, we have S, we have L, and we have
G.
G. Okay, solid, liquid, and gas. So the changes in the states of matter, maybe from solid to liquid, liquid to gas, gas to liquid, liquid to solid, and gas to directly to solid, and vice versa. Solid goes to directly to gas. It is caused by the caused by what, guys? Caused by?
The absorption and the release of
Yes, okay. First, by the absorption and also the release of heat. And that's, okay, all based on kinetic theory of matter, which is atom. Okay, anyone remember what is the kinetic theory of matter states that, what, guys? Anyone remember?
Kinetic theory of matter states that matter is made out of constantly moving small and discrete particles.
Okay, very good. We have two parts to explain. All right. So first, about the size. Okay, they are the particles that are very small and discrete. Okay, you need to memorize that. Okay, and one more. Okay, about the movement. Okay, understand, guys?
Understand, teacher.
So the particles is constantly moving. Constantly moving means that they are moving lah. Alright, okay. And guys, next, okay, matter can change. Matter can change from one state to another state when heat is absorbed or released. Okay, guys, I want you to understand. Okay, that's why I don't want you to have this sequence S, L, and also G. Okay, why? All right, because I want you to understand, okay, when we go this way, okay, from solid, liquid to gas. All right, so guys, anyone, so to change from solid to liquid, liquid to gas, do you think whether their heat is absorbed or heat is released, guys? So we need the cool. Okay, when cool or when heated, guys?
Heated.
When heated. All right. So now, okay, I got the keyboard. Okay, so now, okay, so heat is, you need to understand, heat is absorbed. Okay, heat is absorbed. Okay, we already state this in your flip notes, right? Right, not?
Yes.
Yes,
teacher.
so heat is absorbed. Okay, when
Heated.
yes, when heated. So guys, if the question come out in exam, so you analyze first. Okay, whether they are going this way to your right or going to your left. Okay, meanwhile guys, if the change in state involve to your left side, so means that from gas to liquid to solid, so means that heat is what now, guys?
Release.
Release.
Okay, heat is released now. Heat is released now. Okay, heat is released, and heat is released when heated. When heated also.
When cooled.
When we cool it. Okay, so when cool. Okay, when we put the water in the freezer, so we want the heat away. Okay, so heat away means heat is released. Okay, when cool, you keep cool, and then finally the liquid state, okay, matter, then change to solid state matter. So which is the ice cube lah. Okay, all right. So we just read out the two paragraph right here. There are many substances that undergo changes of matter due to the absorption or release in our life. What happens to the matter when it is absorbed or released? So you need to understand. Okay, heating or cooling can cause changes. Yeah, right. For example, when liquid is cool, it will release heat. So what happens when heat is released? You understand that? Okay, the phrase is, the thing is, you need to understand this one. The particles in the liquid will lose their kinetic energy and then move slower. All right, so that's why, guys, you need to understand that, okay, we explain in terms of this kinetic theory of matter. We need to combine these two things, okay, which are the arrangement of particle and also the movement. Okay, so guys, so based on the first one, okay, for the first one, the particles, okay, lose kinetic energy. Okay, why they lose the kinetic energy now? You need to understand. Why, guys? Heat is form of what, guys? Remember? Form of?
Energy.
Okay, forms of energy. So guys, so if heat is released out, so now kinetic energy possessed by the particle itself also will lose. Okay, all right. So what happens? If lose or if like with energy, so what happened? Moving slower or faster? What do you think?
Slower.
It getting slower lah. Okay, and then what happens to this one for the movement settle. Okay, and then guys, second about the arrangement. Okay, so for the arrangement, the particle will attract one another to change in solid states of matter. What you understand by arrangement? They are now from liquid, so they are getting closer. Okay, attract one another. What is that? I will explain later. It's the force of attraction between particles. Okay, so I will explain later. Okay, the first one is we discuss about what, guys? Heat is released or heat is absorbed? Heat is
Release.
yes,
Released.
release. Okay, release out. Okay, and then second one now we will discuss heat is absorbed. So we understand it is when heated lah. Okay, when a solid. So for example now ice, the one that we kept in the freezer, now we take it away and then the solid heated. Okay, heated by the surrounding temperature, for example. Okay, so the substance now will change to what? Change to from solid, guys.
Liquid.
It changed to liquid when you take it out. All right, so the ice now melt, right or not? turn into liquid or water. Okay, and then lastly change to gas state. All right, and finally boil up and then turn into gaseous state lah. Okay, this all I already show you the video. Okay, during last class, right? Right,
Yeah.
guys? Okay, and then
Yes.
some substances will change directly. Okay. For example, this one. Okay, maybe from solid directly to gas. Okay, you need to understand this very well. Okay, although the name itself is the same thing, okay, sublimation. Okay, but then you need to understand it goes to your right or it goes to your left. If going this way from solid to gas means that heat is
Release.
Release.
solid to gas.
Absorb.
Absorb.
When solid to gas, heat is absorbed. When gas change into solid, guys,
Released.
so it going
Released.
to your left now. So heat is released. So the thing is, before you answer the question, you just draw this diagram. Okay, guys, understand?
Understand, teacher?
Okay, so sublimation. So we have done during sublimation. Okay, what happened? The kinetic theory. Okay, so the same thing. If when heated, the particle gain energy. Okay, from the heat energy, so it will moving faster lah. Okay, you need to understand that. Okay, what about when they moving faster? So what about the arrangement of particle? Is it close pack, guys? No, right?
No.
Will now moving around randomly and faster. Okay, so like this lah. Okay, it's something like this lah, the same thing. Okay, this is S. Okay, this is S, this is L, and this is G. So when going this way is when heated, heat is absorbed. Okay, so you need to understand that. All right. Okay, any question? Any question, guys?
No, teacher.
Okay, so this one. Okay, I think you already understand this. You already learned this during your primary school. Is it? Is it, guys?
Yeah.
Yes, teacher.
Okay, it's actually the same
Yes,
thing
teacher.
as we discussed just now. Okay, the same thing. Okay, we have S, we have L, we have G. Okay, so if going this way, so when heated or when cold? When?
Heated.
When heated. Okay, heat is absorbed or released?
Absorb.
Absorb.
Absorb. Okay, so if going this way, okay, vice versa lah. When cool, okay, all right. So heat is
Release.
so you may have your ice cube here to. Okay, so when cold that way, okay, here you have the gas state, this water, the steam lah. Okay, all right. So now back to the first one. Okay, let's settle the first one. Okay, can you see this, guys? The arrangement of particle. Okay, so
Yes.
if the question asks which states of matter, is a very easy question lah. So it is in what state, guys? What state?
Solid.
Why solid? Justify your answer. Why? Because
The particles arrangement are very close to each other.
because the particle arrangement, they are close packed together. All right, very good. Okay, so now we can see here sublimation, process, from solid to so if you can see here, what states of matter, class, if the question give you this kind of diagram, this one?
Gas.
Why gas?
Because particles are further than each other.
Okay, very far apart. Okay, there are more space, large space between the particles. Okay, all right. So guys, so now the change in state is from solid to liquid, right or not? Right or not?
Yes, teacher.
So from solid to liquid. All right. So it's going to your right. So heat is heat is heat is
Melting.
heat is what, guys? Heat is
Heat is absorbed.
okay. Because the question will ask you, heat is absorbed, heat is released. And then they will ask you when heated, when cold. You need to understand that. Okay, class. Okay, so guys, so usually you observe the ice, okay, turn into gas. Okay, so for example, this in our daily life is just the mothball, okay, and then what else we have? The naphthalene, okay, it just disappear. And the dry ice, okay, okay, so it just disappear from solid, then turn into gas. The gas state we can't see anymore. Okay, guys, so you need to understand heat is absorbed. Why the heat is absorbed? Okay, because they tend to break the bond of between the particle, and that's why the particle will go far apart lah between each other. You need to understand that. Okay? Boleh? Okay, guys?
Okay, teacher.
And then, guys, okay, for another type of sublimation here, we have from liquid to gas. From liquid to gas. From liquid, okay, from liquid right back to, okay, just now, from solid to liquid. Now, liquid to, sorry, guys, this is not liquid lah. This is not liquid,
Solid
guys.
to gas.
Gas lah. Solid to gas. Alright. Okay, gas. Okay, gas. Okay, gas. So from gas now to solid directly. There is no intermediate to the liquid. So, okay, sublimation is the answer. Heat is released now. Okay? Why heat is released? You need to understand. Heat is not used now, right? It's not absorbed to broken down because they are formed the particle. They are formed the bonding between the particle. So heat is away lah. Heat is absorbed. Heat is released away. Understand, guys? Boleh? Okay, so now next. Okay, for example, we start with the, okay, if you can see here, the arrow with red in color shows the heat is absorb. So heat is absorb is something like, okay, if we have the container, you put inside the ice cube, okay, so you supply with the heat, okay, so heat supply. So what you observe next, guys? What happened after 5 minutes? What happened?
The ice melted.
The ice now melted, turned into liquid. So now heat is used to broken down the space between the particle that they are packed together in solid state just now and now turn into liquid. So the heat will broken down the bonding between the particles. Okay, guys? All right. So okay, later I will show you in the diagram later. Okay, so now, okay, so vice versa lah. Heat is released means that we don't want this heat. Okay, so now what happened from, okay, they are very loose, okay, then getting closer now to turn into solid. Understand?
Yes, teacher.
Okay, so now, okay, let's discuss about freeze. Okay, this one is melting, right? This one is melting. Okay, so this one lah, heat is absorbed, settle. Okay, and then heat is released, is freezing lah, from liquid to solid. Okay, all right, and last one, condensation. Okay, condensation and more. Okay, why, guys? Okay, we go to this one first. Okay, okay. For boiling and evaporation. So if the question asks you to state, okay, what is the physical processes that involve the change in state from liquid to gas? 2 marks. What is the answer? Guys? Anyone?
Vaporizing.
boiling and evaporation.
Boiling
Evaporation.
If 2 marks, okay, means that PT3 format, they need 2 answers. Okay, so the answers are, okay, 2, boiling and evaporation. Okay, guys, okay. Okay, both, okay, what is the similarity between, what is similar between the boiling and also evaporation? Both, when we discuss about similarity, remember, we need to start with what word, guys?
Liquid turns into gas.
I mean, when we want to discuss about similarities, we start with what word?
Both.
Both. Very good. So, both boiling and evaporation involve the change in state from
Liquid to gas.
Gas.
gas to liquid pula. Liquid to
Gas.
liquid to gas. Evaporation. Evaporation. Okay, so okay, now when we discuss in aspect of the change in state, they are both the same thing. But then, guys, okay, the different thing between, there are many differences between boiling and evaporation. Okay. Okay, guys. Later we will observe. Later we will discuss. Okay, and last, condensation. Condensation is change in state from.
Gas to liquid.
Gas to liquid.
Okay,
Gas
gas to liquid. Very good. Heat is absorbed or released?
Release.
Release.
Okay, gas to liquid. So it going this way, right? So release. Okay. All right, guys. Okay, so now I want you to have your flip notes now. Okay, are you ready with your flip notes?
Yes,
I have my
Yes,
one
teacher.
here also. Okay, so ready? So let's start with the cover first. Okay, so for your cover, okay, guys. Teacher, I close my camera because I want to use this. Okay. You can see, guys, anything? No.
Can.
Okay. Can see or not?
Can, teacher.
Okay,
Yes,
can.
teacher.
Okay, so let's start chapter. What chapter? Which one? Which chapter now? We are
Chapter 5.
yes, chapter 5. What is that? Our last chapter now.
Metal.
Metal.
Okay, metal.
Metal.
Down. Okay, metal. Okay. All right. Okay, so now, okay, activity. So activity is from, okay, so for this one is, activity is solid, liquid to gas. This all. Okay. All right. Okay, so then write down your name, your class. Okay, you're done, right, guys?
Yes, teacher.
Okay, now next. Okay. All right. Okay, so now, okay, let's continue with the first step. Are you ready, guys? Done?
Can, teacher.
Okay. Okay, so for tab number 1, okay, you ready? Okay, for tab number 1, let's discuss about sublimation. Okay. Guys, sublimation. So, sublimation. Okay, for sublimation. All right. So, what is the change in state involved, guys, here? Change in states of matter. It is from?
Solid to gas.
Solid to gas.
We have solid to gas. And also, only solid to gas.
Gas.
Gas to solid.
Gas to solid as well. Don't forget. Because student most missing marks for that one. Okay? All right. Okay, and then second. Okay, second is melting. Okay, this will be your homework lah. Okay? Okay, melting is what states of matter, guys? Change in state from?
Solid to liquid.
Solid to liquid.
Okay.
Solid to liquid.
To liquid. Okay. If the question asks you, okay, please state in full lah. Solid to liquid. I just use the short form here lah. Okay. And then 3, guys. Okay. Choose boiling. Okay. Okay. Boiling is change in state. What is change?
Liquid to gas.
Liquid to gas.
Okay. Liquid to gas. All right. Very good. Okay. And then number 4. Okay, number 4 is evaporation. So guys, later we will discuss what is the difference between tab number 3 and 4. Okay, because they are both share the same change in state, which is what is
Liquid
it?
to gas.
Liquid to gas.
Okay, liquid to gas as well. All right. Okay, and then number 4, okay, it is for condensation. Okay. Condensation, guys, from what states of matter?
Gas to liquid.
liquid.
Okay, gas to liquid. All right. And then 6, we have freezing. Okay, freezing what states of matter, guys?
Liquid to solid.
Liquid to solid.
Okay, liquid to solid. All right. And last one. Okay, last one. Okay, last one is just diagram. Okay, later I ask you to draw the diagram. Okay, it is actually figure 5.14. Okay, guys, got it? Got it, guys?
Yes, teacher.
Yes, teacher.
Maybe you may add on right here a bit on the effect of heating on matter. Okay. All right.
Teacher, the effect of heating on matter is for activity name as well.
The one is the topic lah. You just the activity is SLG, but you may jot down also lah. Okay. Okay, ready, guys? Okay, done. Okay, for those already done preparing the tab, okay, proceed to tab number 1, which is sublimation. Okay, so please give me the definition of sublimation.
Sublimation is a process in which a solid directly turns into gas or a gas directly turns into solid.
Very good. Okay, bear in mind, okay, got student always missing, okay, they only mention one side only. You need to state for both, okay, for sublimation. So, is a process, okay, is a process in which, okay, in which a solid, the one that you have already write down just now, right, is actually solid to gas and also gas to solid. Okay, so which a solid directly, you must have the word directly. Okay, directly turns into gas. Okay, or or
Gas
gas,
directly turns into solid.
gas directly turn. Usually this kind of question for sublimation 2 marks lah, or maybe 1 marks. Okay, but then you need to state both. Directly turns into solid because definition usually 1 mark. Okay, turns into solid. Okay, done. Okay, next. So next, change in state. If the question asks you, please state the change in states of matter for sublimation. So how to answer the question? Please don't use the short form. You need to state in full. And you need to bear in mind, we do have 2 for sublimation. Okay. A solid, okay, solid to gas. Okay, so solid to gas, guys. Heat is absorbed or released?
Absorb.
Yes.
Absorb.
Okay, so heat is absorbed. We are doing the flip notes together now. I don't want you to do homework because you never do your homework. Right or not? No. Okay, gas to
Solid.
solid. Okay, so for gas to solid, heat is?
Released.
Okay. Heat is released. Okay, as analogy, what I can, okay, later lah. I want to discuss about force of attraction later. Okay, it's okay. Alright, done guys?
Yes, teacher.
Okay, very good. Okay, so now we're gonna to have this kind of format for all texts. 1, 2, 3, 4, 5, and 6. Got it, guys? Got it or not?
Yes, teacher.
Okay, so now let's move on to tab number. Okay, tabs number 2. The change in state is, sorry, the process is what? Yes, anyone? Melting, very good. Okay, the process is melting. Okay, so what is the process name for melting? The definition? Anyone?
Solid absorbs heat when heated.
Okay, definition. When the question asks you, melting is what? Melting, is it a process? Is it a movement? A theory? What is melting? Actually, it is a
Process.
Process in which a solid turns into liquid.
Okay, so as simple as first when we have the word melting, boiling, sublimation, condensation and all, okay, first you just analyze the change in state is from what?
Solid to
Solid
liquid.
to liquid.
Solid to liquid, right? So to define, so we start with the word a process in which
A solid turns into liquid.
a solid turns into
Liquid.
liquid. Very good. Okay, must add on some more. Must add on some more. When it reach what?
Example.
It reach?
Melting point.
Yes, very good. Okay, must. Okay, it is must to reach the melting point. Because if the particles didn't reach up yet the melting point, so it can't melt. Understand or not, guys? Okay. So next is change in states of matter. Please give me of matter.
Solid to liquid.
Yeah, solid to liquid. And usually for this kind of question, they ask you to put the change in state and then explain. One more mark. Okay, justify your answer. So you said lah.
Heat is absorbed.
Absorb.
Okay, right, like that. A solid to liquid. Heat is
Absorbed.
absorb. Very good. Okay. All right. All right. So, okay. Okay, guys, if the question asks hello guys, can see or not?
Yes,
Yes, teacher.
Sorry. We have in my house now got blackout just now. Okay, it's okay now. All right. Okay, let's continue. Are you okay, guys?
Yes, teacher.
Okay,
Yes,
let's
teacher.
yeah. Okay. So guys, so let's continue. Okay, heat is absorbed just now. All right. So now, okay, the critical things to explain this one maybe 3 marks. Okay, for the question. Okay, you need to explain what happens during melting process. Okay, right? Okay. Wait, okay, just continue. Okay, to define the melting process. Okay. So guys, first, melting is the process of in which a
A solid turns into liquid.
Solid turns into a liquid.
okay, so how to define first? Okay, we need to okay, the description on the process. Okay, so first we need to start with solid. Understand, guys? Okay, so we start with the word solid. Okay, what happened to solid, guys? Because we have the word solid right here also. Solid to liquid and heat is absorbed, right or not? Okay, how to explain? So we need to start with the word solid. Okay, what happened to solid? Particles, guys. Solid. Solid.
The solid particles will start to move freely when the temperature reaches melting point.
That one is conclusion already. Step by step, guys. Who is that? Step by step.
Ashwin.
Tashwin, we go step by step. First, solid. What happened to solid? To change to liquid. Okay, so now guys, we need to become the particle of solid. Okay, let's become the particle of solid. Okay, so we are now solid particles like this. Okay, this is solid particles, right or not? Okay, so for melting is something like, okay, these particles are now, okay, right? 1, 2, 3 must be equal lah. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, how this solid particle change, okay, to liquid? So we need to explain this. Alright, so first, solid. Okay, how the solid can change into liquid? Solid must do what? First, guys.
Solid absorbs
heat.
So first,
Absorb
solid
heat.
absorbs heat. Okay, absorb heat. Okay, when?
heated.
Very good. So these there's these 4 words you need to get familiar with lah. Okay, solid absorb heat when heated. Okay, then when the solid particle, we are now solid particle, we are very close packed together now. But then guys, okay, what you need to understand here, I want you to understand, heat is like, okay, solid, okay, what you can see here, solid is very close packed together, right? Right or not?
Yes.
Yes, it is like our close friend, right? You are very close with your friend, very close between each other, very close. Okay, but then guys, we have this H is the enemy. Okay, so what happened? Heat now will break down all the you jadi close friend, right? It will break down all the bonding. Okay? Between the particles. So what happened? So this one still be close friend, but the others, so the heat is enemy. Very keep smiling lah. If they tend to make you separate. Okay, like this. Understand or not, guys? Boleh?
Yes.
Okay, so now, all right. So what happened next after solid absorb heat?
The particles obtain energy and vibrate faster.
Yes, okay. So back to the, okay, the one that we discussed. Okay, solid particle can moving around or not, guys? Solid?
Cannot.
Cannot, right?
No.
They are just vibrate about at fixed position, right? Right or not?
Yes.
Okay,
Yes.
look at here. Okay, if you are a solid particle, can you moving around, guys? No, right? Okay, because they are very packed together, because there are less space to move around, right or not? So now,
Yes.
okay, in between the way that they want to change into the liquid, what happened? Because we have these heats. Okay, when we have these heats, the particle now, you kan dapat ada kawan baru datang, so you dah tak ingat dah yang lain. Alright, so the old friends, so the particles now obtain the heat.
Energy.
Obtain the heat energy. And what happened to your vibration? Just now, you just jalan with your friend, you walk around with your friend, and now you have your new friends known as heat now. You just,
Vibrate faster.
you action lah and vibrate faster. Like that. And vibrate faster. Okay. Vibrate faster. Okay, and then guys, what happened? Okay, so you need to understand why we need to absorb, why the particles need to absorb the heat to become liquid. Okay, because heat is used, to
Overcome the force of attraction between the particles.
Yes, because this kind of question also may ask you, okay, why the heat is absorbed? So you need to understand, we want to break this bonding, the bonding known as force of attraction between particle. Okay, attraction. You understand or not by the word attraction? Guys?
Yes.
Yes.
Tarikan.
Tertarik. Okay, tarikan kan. Attraction. Sorry. Okay. Guys, you dekat mana dah tu? Heat is used to overcome
The force of attraction between the particles.
the force of attraction. Sorry. The force of attraction. So you know by now what is the force attraction between the particles? Yes or no? So guys,
Bonding.
so what do you think now? Chemistry is difficult than biology? Okay, it's something like this lah. Okay, I show you. Okay, what is this I'm drawing now, guys? Guys?
Particle.
Very
Particle.
good. Understand now. Okay, the particles. Okay, and then what I have now here?
Another particle.
Very good. Now?
Another
Another particle.
Very good. This one?
Another particle.
Another one.
particle.
Good. Okay, very good. So now, okay, this one. Draw like this. So now, okay, I have this one. What is this? This is called, the force of attraction between particles. Okay, force of attraction between particles. So guys, so which one do you think? Okay, when we discuss about force of attraction, got two only. Okay, sorry, not here. Got two only. Can you choose whether they are strong or weak? So I have A and B. So what do you think? Which one got stronger force of attraction? Guys, A or B?
B.
Strong attraction between the particle. A or B, guys?
A.
B.
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 Or B? Okay. How to okay, I give you analogy, right? So this one, your friend, this is you, and this is your friend. Friend, not boyfriend, friend. Okay, A and B. So now this one's your this friend of you now is close to you. So it is your close friend, right or not? Rather than this one, you never interact or never communicate also. So only you okay? Understand or not? So this one will have the stronger force of attraction. Understand? Kenapa? Why you have your close friend? Because you suka sama, you do same thing together, right? You love the same thing as well. Understand or not? You share the same preference also, like that. That is close friend. Guys? Hello? Hello, guys?
Yes.
Yes.
I know we are now basically, yeah, we are not connected with our friend, right? So very sad, right? So but then we need to admit lah, okay, this situation now, right? Okay, but it's okay, we have this in our chemistry. Okay, do you love chemistry, guys? Okay, guys. All right, so now, okay, so now from solid and liquid, so now we have heat. Remember, heat will overcome, okay, the force of attraction between the particles. Means that for solid, okay, they are basically first, okay, at initial point as solid, they have very close packed together, right or not? Right or not? The force of attraction between the particle is very strong. So now what happened? It's loose now, and the bonding now is broken down, and it now becomes solid. Become liquid. Understand not? Understand not?
Listen,
Yes,
teacher.
teacher. Yes.
Then only the solid, okay, we are no longer can say as solid lah. They are intermediate something here lah now. Okay, because heat is used now, heat is supply now. So what happened? Now the particles now, they are tend to be solid, liquid state lah. So the liquid now, is it vibrate about at fixed position, guys? What is the characteristic for liquid? The movement of liquid.
Move freely.
That's why now the particle move freely. Okay? Move freely when the temperature,
Reaches melting point.
reaches the melting point. Okay, for the melting point of water is what? What is MP for water, guys?
100 degree.
Zero.
Zero Celsius.
0.
0 degree Celsius. Understand, guys? Can or not? Can or not, guys?
Yes.
Yes.
Can,
Teacher.
teacher.
Okay. Can absorb or cannot? Still can absorb or not, guys?
Can.
Can. Okay, very good. I like that spirit. Okay, so let's move on to tab number 3. Okay. All right. So for tab number 3, okay, let's proceed tab number 3. Okay, this is about what, guys?
Boiling.
Boiling.
This one is a very important one. I want to continue for boiling and evaporation. Okay. All right. So now, okay, we do a bit faster lah. Okay, for boiling first. Okay, definition. I think everyone know already how to define. Okay, please give me the definition. A process.
In which liquid turns into gas.
Okay, very good. So how? Okay, how? So please state first the change in state liquid to gas. So to define, need to have the word a
Process.
A process.
So a process in which a liquid turn into gas. Turn into gas when
The temperature of the liquid is equal to the boiling point of the liquid.
when it as simple as when it reaches the boiling.
Boiling point.
Same as melting just now. You just rephrase with the change in state now. Understand, guys? Understand?
Yes, teacher.
Okay, so the same way as melting, you jot down the change in state. Okay, so what is the change in state for boiling? Just now we have mentioned liquid to
Gas.
gas. So heat is
Absorb.
absorbed. Very good. Okay, so now are we continue with description only? Okay, so description. So everyone ready with the description? So we start with what? We start with what? Guys. We start with
Boiling occurs when the temperature of the liquid is equal to the boiling point of the liquid.
okay, that one will be the conclusion. Okay, we want to describe like melting up here.
Liquid absorbs heat when
Must start with the word liquid lah. Okay, so liquid absorb heat when
hot.
when heated. And then second point, what is that? The
Particles obtain energy and move faster.
obtain energy and move faster. Guys, why we just use the word faster? We just use the word faster lah. Alright. Okay, then continue, guys. Next, okay, so now heat is used for what? Okay, so guys, this is actually
Break the bond between the
liquid particles.
Okay. We go to the melting first. You can see here to overcome the force of attraction between the particles, because your textbook just want you to have more vocab, more terminology on this lah. So you may use this term also instead of the melting point, just the same thing as well. So heat is used, this one is simple, I think, right or not? Heat is used to break. This one is simpler lah. Okay, break the bond between the
Liquid particles.
between the liquid particles, to be specific lah. Okay, if you state only the particle as well can be accepted. Alright, so that one, that's all. Okay, and then okay, and last one, guys. You may refer your textbook also. Same as melting. Particle move friendly when okay, so now liquid tend to change into gas, right? So guys, so now the particles now when is tend to be liquid or gas now, guys? Liquid or gas? They are now
gas.
they are now change into gas state now. Okay, all right. When the temperature reaches, okay, the temperature reaches what, guys? What do you think? If
Boiling point.
Very
Boiling point.
Okay, because because now for melting is going to change into liquid. So it move freely as liquid and it reaches the melting point. Okay, meanwhile for boiling, when the temperature reaches the
Point.
Boiling point.
the boiling point. Very good. And what happened to particle when they reach the boiling point?
They move freely and
The
randomly.
particles.
Ah,
Yeah.
they now behave like gases, right or not? Right.
Yes, teacher.
Yes. Do you have the pattern now, guys? Do you understand?
Yes, teacher.
Okay,
teacher.
freely and randomly, because now we are define the characteristic on gas state. Very good, well done. Okay, break the bond. So it's just the same thing as force of attraction between the particle. Nanti when you learn chemistry, you know about it better lah. Okay, the temperature reaches the boiling point because we discussed the boiling now. The particle move freely and randomly because they are now behave like gas state. Okay, so this is for boiling. Okay, we have done with this boiling. Okay. Now, okay, let's continue with tab number 4, which is
Evaporation.
okay for evaporation. I want to discuss evaporation and then next condensation. Evaporation is the change in state. What is the change in state, guys? Guys, what is change in state?
Liquid to gas.
Liquid to gas.
Liquid to gas. Very good. Okay, very good. So liquid to gas. Very good. It's just the same with what? Just now.
Boiling.
Boiling.
Boiling. Okay. Oh, sorry guys. I forgot one thing. The one that mentioned by Esther just now. Forgot lah. Okay, may I add on? I add on here lah. Teacher, add on here. Okay. Boiling just occurs. Boiling
Occurs when the temperature of the liquid is equal to the boiling point of the liquid.
Okay. So, but these things are actually define the last thing lah. Okay, when the temperature, this one, right? Okay, when the temperature reach the boiling point, then only it will boil. Right? No, you understand, right? No need lah. Okay, just continue with this lah, evaporation. Okay, evaporation same as just now. Okay. Okay, you define the definition, may start with the word process. Right or not? A process. Anyone, please tell me what is the definition on evaporation, please? A process.
A process in which a liquid turns into gas.
Okay, that's all. That's all. Okay, evaporation. Do we have any evaporation point?
No.
No.
All right. That's the first difference between evaporation and
Boiling.
boiling. Which a liquid turns into gas. Okay, because this one, guys, for boiling, they need to reach the boiling point. But for evaporation, is there any evaporation point? No, right? So it happens at any temperature. Understand, right? Because this one you will study more in form 2 about rate of evaporation. Okay, you will study this one for the details during form 2 lah. Okay, so change in state same as boiling. Okay, so let's discuss the description only lah. Okay, so for the description, okay, okay, number 1 must start with word. What word?
Liquid.
Liquid. Very good. So liquid Do what?
Absorb heat from the surroundings.
Okay, very good. Absorbs heat.
From the surroundings.
Okay, because they never have any boiling point, evaporation point, and whatsoever. So the liquid just absorb heat from surroundings. Okay, that's why you need you already observe this. If you just dry out your clothes in your room as compared rate of evaporation, right? So you will study that during form 2 later lah. Okay, so next, the particles obtain
Energy and move
and
faster.
move faster, same as boiling. Okay, I don't want to continue. Okay, the third one, this one will be the second differences. Okay, between boiling and this one is the same thing lah. Evaporation occurs at any temperature. I already add on there. Okay, you just add on. Okay, satu lagi. Add on some more. Just happen on the surface of liquid. Okay. They are going, okay, the process happen by surface. Okay, meanwhile boiling for the whole liquid. Understand? Can you already observe this, when you boil the water, what you have there inside, we have actually inside convection current boiling. Okay, so the whole liquid will boil, right or not? Right or not, guys?
That's
Right,
good.
teacher.
Okay, for example, I draw for you. Okay, so for example, when we heat up, okay, this water, because now we will discuss about liquid. Okay, so now what happens? Okay, because we will observe the convection current inside. Okay, which is to boil up. Okay, so it's actually involve entire or the whole liquid. But then for evaporation, okay, if we just it will dry out, okay, by surface only. It takes a longer time lah than the boiling. Okay, so I want to ask you back question. If we have, you need to do or carry out experiment, okay, the task is instructed you to evaporate the substance, okay, the substance. So how to increase the rate of evaporation? So the answer is
Heat the substance.
yes, heat the substance to speed up. Okay, speed up. Okay, understand, guys? But then must be lower than boiling point lah. Okay, nanti your substance melt. Tak mau lah. Okay, alright. So now, okay, next. Okay, number 5. Okay, for number 5 is something like we going different way, right? Not? Because now heat is released, right? Not? Yes or no, guys?
Yes.
Yes. Okay, I use the green color lah. Okay, for tab 5. Okay, we start with condensation. Okay, for condensation, okay, so same thing as, okay, as simple as a process in which gas
Turns into liquid.
turn into liquid. That's all. Okay, all right. So change in state, guys. Gas to gas to
liquid.
heat is
Release.
release. Very good. Okay, a bit description on condensation. So guys, okay, so we need to start with which state, guys? Because it's gas to solid to liquid, right? So yes. Very good. Okay, just now we have liquid absorb. So now gas
Release heat.
We are doing the same pattern but different way round. Okay, gas released, heat when heated,
Cool.
when cooled. Okay. So what happens? What happened next?
The particles lose energy and move slower and closer to one another.
Very good. Okay, so now they are poses to become liquid now, right? Okay, the particles
Lose energy.
Okay. Okay, the word just now obtain energy, right? So now vice versa. Okay, terbalik opposite ways. So we have lose energy. Very good. Lose energy. And what about the movement?
Move slower.
Is it move faster? Yeah, move slower. Okay, opposite way. Okay, so now it move slower. Okay, and what happened to the arrangement? And
Closer to each
Closer.
other.
it get closer to one another. Okay, how to? Okay, I give you another analogy. To closer to another. To one another lah. To one another. Okay, so now we have gas state. 1, 2, 3, 4, 5, 6, 7, 8, 9. Usually the gas state the particle should be equals in size. Ni a bit different. It's okay lah. Alright, so now 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so now gas to liquid. So now gas release heat. So now guys, so now there are no more the heat. The enemy now is no longer here. Okay, so now they make friend lah. So it getting closer, and you move slower lah sebab tadi tak nak kawan kan. So you move slower and get back to your friends. Okay. Alright. Okay, it's okay. It's okay. We just accept as friends. Okay. So and then next, when?
Teacher, for the particles arrangements, must we draw 9 particles or?
No need. This one just analogy. I show you only. No need. Okay. Alright. If the question asks to draw only draw the particles. Alright. Okay. And then next class, when the
temperature is equal to or below the boiling point, gas will turn into liquid.
Okay. When the temperature is equal to or below, usually below guys. Okay, or below the boiling points. Okay? Okay, so the gas will turn into liquid. Below the boiling. Do you remember the video that I just showed you just last Thursday? Guys?
Yes.
Okay, gas will turn into liquid back lah. Alright. Okay, because we just cooled it down. Okay. Alright, so we have done with condensation. And okay, last one, I want you to, okay, for last one, I continue lah a bit only. Okay, last step is about step 6.
Freezing.
Freezing, very good. Okay. Alright, so 6 is freezing. So freezing, okay, what is the definition? A process.
A process in which liquid turns into solid.
Liquid turn into solid. That's all. Remember, do we have
When cool.
when cold? Do we have freezing point?
Yes, teacher.
Yes,
When it
teacher.
reaches freezing point.
Very good. A process in which a liquid turns into solid when it reaches the
Freezing point.
freezing point. Very good. Must have that one, remember, Okay. All right. So you continue that. All right. Don't forget the change in states. Okay. Change in state of matter. So the change in state we have stated there. Okay. Is actually from
Liquid to solid.
liquid to solid. So heat is
Release.
yes, heat is released. Okay, let's continue for the last one. Description. Description. Okay, must start with what word?
Liquid.
Very good. So liquid what?
Liquid releases heat when it is cooled.
Very good. The same thing lah. Okay, liquid releases heat when cool. Okay, then next, particle. Particle.
Use energy and move slower.
You may use the same pattern as well. Can. But then the last one need to change a bit. Okay, so next the particles. Okay, as same as condensation. Okay, very good. Okay, you have studied this before, right? During your primary school, but you never discussed in this detail, right? Right, not?
Yes.
Okay, but then this is chemistry lah, so you need to understand. Okay, remember the chemistry? We can see, but it's there. Alright, so now, okay, because we want to show the movement of particle, the characteristic from liquid now change into solid. So what happens to the particles? Particles
Start to vibrate at a fixed position when they reach freezing point.
yes, because a vibrate at fixed position is actually characteristic of
Solid.
so after freezing, okay, we need to conclude until they change totally and become solid. Okay, at a fixed position. Okay. Alright, so it's 4:30 now. It at a fixed position. Fixed position. Okay. When they reach, must end up with this one. When they reach,
Freezing point.
The freezing point.
very good. What is the freezing point of water, guys?
0 degrees Celsius.
0 Celsius.
0
Okay. Freezing point of water is, yes, is as same as, remember in the video they say the melting point will be the same as the freezing
point.
freezing point. Very good. Okay. All right. And then last one for tab number 7. Okay. Tab number 7, you just draw the figure 5.14 that I have mentioned just that we have discussed earlier. All right. Boleh?
Cancel.
Okay. And guys, okay. All right. So I'm stop sharing now. Okay. Let's stop sharing. Stop presenting. Okay. Can see me or not? No, cannot. Because I'm not. Okay. Can see me or not? Okay.
Yes, teacher. For the figure 5.14,
Okay.
can we print it out?
Yeah, sure can. Okay. Teacher, what page? Okay, what page? Let's continue back here. Okay, this page. Okay, the one that we discussed earlier. That's this thing. Page 152. Okay. Can see or not? Can see or not, guys?
Oh, teacher, you're not sharing. the screen.
Not sharing. Okay, sorry. Okay, I'm sharing the screen now. That's why I need to have that SOP kan. Alright, I'm sharing the screen now. Okay, can see now?
Yes, teacher.
Yes, teacher.
Yes,
This is the, okay, this is the figure for 5.14. Okay, the one that we discussed. Alright, just now. Okay, so guys, okay, stop presenting for a while. Okay, I want to show you this. Okay, guys, for tab 7, you will have this diagram like this. Okay, on top here, I want you to copy down from page 153. Okay, I will share the screen now, 153. So, what is 153? I want to discuss, so we will finish up this. Okay. Can see or not, guys? Okay, can see now. Okay, I want you, okay, this one is actually the one that we discussed just now. Everything settled. Okay, so this one. Okay, science in life. Okay, can see or not?
Yes,
Yes, teacher.
Okay, lagging. All right. Okay, so we have there boiling. Sorry, it's lagging. Okay, sorry, I close this one first. Okay, alamak, too small. Okay, everyone, turn page 153, your textbook lah. You have or not with you?
Yes, teacher.
Yes, teacher.
Okay. All right, very good. Okay, so here, science in life. Look at the bubbles. Usually, okay, when the liquid about to turn into gas, so we will have the bubbles lah. So it is gas or liquid. All right. Is it actually what, guys? Is it? It is. The bubbles are actually a
Thin layer of
liquid
gas.
thin layer of liquid that containing gas inside. The bubbles is actually, okay, the outside one, okay, the outer one is a layer of liquid, but then inside gases. All right, so the gas is wait for the boiling point to escape and turn into gas state. All right, okay, this all is the experiment. Okay, is the activity only lah, so we skip this one. Okay, but we discuss the outcome for the experiment because we only discuss details for the experiment wajib sahaja. Alright, so guys, so this one, I want you to copy down this one. Okay, before you copy, we discuss this one first. Okay, because this is the statement in chemistry lah, a bit on chemistry. So, okay, when a substance is heated, okay, when a substance heated, what you understand? When heated, what you understand, guys? When heated,
Absorb heat.
yes, absorb heat. Very good. So when we use the temperature, when we use the thermometer to measure what, guys? To measure what? What is the use of thermometer?
To measure the temperature.
Thermometer is used to measure the temperature. And what is temperature? Anyone? What is temperature? Anyone? What is temperature? Guys, anyone? What is temperature? Temperature is the degree of hotness of the substance. It's actually hotness or coldness of the substance, but usually we use the hotness because we actually measure the kinetic energy possessed by the particle in the substance. Okay, guys? So when the substance is heated, you understand that heat is absorbed, right or not? So what happens to the temperature, guys? The temperature
will increase.
Yes, increase. You may observe the rise in the reading of the temperature, right or not? Right or not? Right or not, guys?
Yes.
Yes, okay, very good. So first, you need to understand. And second, vice versa is the opposite way. So when we cool, what happened? What happened? The temperature?
Will decrease.
The will decrease. Okay, will decrease. So you understand these two sentence now? Can be accepted or not? Yes, okay. However, okay, we have the word. This for your information. In chemistry, we do have many exception, many however. Okay. So the temperature will not change. What you understand by the word will not change? Guys.
Remains constant.
Very good. Remain constant. Unchanged. Okay. So the temperature will not change. Remain constant. Okay. All right. When? When it reaches what? Reaches
Freezing point, melting point, and boiling point.
Yes, freezing point, melting point, boiling point. For example, okay, I will give you another analogy. Okay, we have, okay, that's why I asked you to bring your water, a glass of water, guys.
Yes, teacher.
Yes, teacher.
Yes, teacher.
What is inside your glass or cup or mug now?
Liquid.
Liquid.
Liquid. What states? What states of
Liquid.
matter?
Liquid. Liquid.
Very good. Okay, so guys, so this water, okay, may I ask you what is the temperature of the water now?
Room temperature.
Yes, room temperature. If you in the cold room, you have aircon, so your water will, the temperature will decrease, right or not? So you
Yes.
just like you drink cold water, right? Okay. Meanwhile, if you there's maybe just next door, okay, near the door, okay, we have the sun exposed to the suns, so it's got okay, so the temperature will
Increase.
increase. Or you just warm up your water, you just hold your glass for a while, so it will increase also due to your body temperature as well. Understand or not, guys? Understand?
Understand.
Okay, so now the temperature. But then, guys, so the water, if you heat this water, what happens to the temperature now? Is it same as the one that you just drink just now? Yes or no?
No.
No, the temperature now increased, right or not? Increasing, right?
Yes, teacher.
Okay, for
Yes.
example, my room now is 32 degrees Celsius. So hot today, Okay, so it's 32 degree, and then when you heat up, okay, maybe you turn on the stove there in the kitchen, you turn on, so you will observe the temperature of the water now will increase to 40, 50, 60, 80, 90, and 100. Okay, in between there, you may see the bubbles. Okay, what is the bubbles there just now? Is it gas or liquid, guys? The bubbles is actually
A thin layer of liquid
Thin layer.
containing gas.
a thin layer. Maybe the temperature now is 99.99999. Okay, so the bubble ready to escape to become a gas state, to change into gas state. All right. Okay, so guys, when now they reach already the gas state 100 degrees Celsius, so it's already turned into gas. So do you think when you measure the water, is it increasing to 101, 101, 102, 103, 104? What do you think? Is it
No.
increasing?
No.
Okay, all right. So supposed to be it increasing, right or not? Right or not? Right? No.
Yes.
Yes, but you need to understand. Suppose it increasing because heat is heated, temperature increase. You need to understand. But then during we discuss now for boiling point lah. Okay, so the heat is absorbed, right or not? Boiling. Heat is absorbed to overcome the force of attraction between the particles. So that's why dia tak boleh increase because it is absorbed by, it is used by to overcome the force of attraction. Understand or not, guys? Understand or not?
Understand,
Yes,
teacher.
teacher.
Okay, it is like just like you simpan your money into your saving lah. Okay, but then if you keep on save your money, so your money should be
Increase.
increase, right? But then in the kind of quick situation, you need to use it maybe to buy this, to buy that. Okay, so the money is not increased lah. Something like that. Understand or not? Understand or not?
Yes, teacher.
Yes, teacher.
So this will be the famous question also. They will ask you why they will ask is the temperature is will increase to 200. So you need to understand lah. So the answer is no. The temperature will remain constant. Why? The second question will ask you why. So the answer is
Heat is absorbed or released to overcome
no, because
the
if the question focus on boiling is heat absorbed, right? So you don't use this one. Okay, so
Okay.
we use this one to overcome the force. Okay, because if heat please clear in mind because this one is the sentence from the theory. Okay, that's why like that. Heat is absorbed. You need to understand this one. Heat is absorbed. Okay, why the heat is absorbed? Okay, because to overcome. Okay, teacher tulis somewhat sikit. To overcome the force. What is the meaning of to overcome? To break down. Understand?
Yes.
Okay. In other way around, if heat is released, it is actually to
form.
Break the bond.
form. Okay. And so this sentence is slightly confusing. Right or not? Okay, they combine both for both. Okay. All right. I hope you understand, guys. Can or not?
Can, teacher.
Can, teacher.
Okay, so now we understand. Remember the learning objective, all right? So the temperature will remain constant at freezing point, melting point, and boiling point. So we have done with that one. Okay, next we will discuss about mass. Okay, what happens to the mass? Is it constant? Is it change? Okay, during the physical changes, guys. Okay, so physical changes means that the physical PP lah. Okay, the one that we discussed. Okay, PP. Okay, the change in states of matter, melting, boiling, okay, and everything. So what happened? For the mass remain constant also because you need to understand what is the mass. What is mass? What is mass, guys?
Quantity of matter in an object.
Very good. The amount of matter. That's why, okay, because you already studied this one, I want you to understand this very, very, okay, for solid and liquid. That's why if you're drawing 9, okay, all right, so 9 particles, so this one also 9. So you may understand that the particle have same mass. Okay, mass remain constant. They are not changed. Okay, because guys, the quantity is not changed. Okay, because the quantity of particle is actually the what is the quantity of particle? What is the quantity of particle just now? It is
Mass.
is the mass. So the mass is not changed. The one that changed is
The kinetic energy.
Okay. Remember they're moving faster, right or not? Right or not, guys?
Yes.
Then only when the particles inside the substance moving faster, so what happens is actually gain energy. Remember obtain energy just now? Obtain energy. So what increase the kinetic energy? Okay, you understand? Kinetic energy is the energy possessed by the moving object. They're moving faster and faster, and by observation, we can see the rise up of the temperature. Understand, guys?
Understood, teacher.
This is chemistry, yeah, for your information. Okay, all right. So guys, last one for today. Okay, example of change is of states of matter. Okay, so we have here, can see or not? Okay, first one, water. Water from wet items. Water from wet items. So from liquid, they evaporate, right? To
Gas.
Water vapor.
to water vapor lah. From water to water vapor. Okay. Water to water vapor. Okay, and then we have the freezing to allow sweet ice cream. But then vice versa lah, melt of the ice cream. Okay, and then the dry ice. Okay, all right, the dry ice. Okay, dry ice. Okay, is actually why the name is dry ice? Do you understand? It's actually from solid change into
Gas.
Yes.
directly into gas. Okay, all right. Okay, and then we have the mothballs. Okay, become smaller that we can have the intermediate, for example, liquid or anything. So it just disappear. All right. So this is from solid to gas also. And also the dew is formed when water vapor. Okay, so the word vapor also by the condense of the air surroundings lah. Okay. All right. So I think that's all for today. Any question, guys?
No, teacher.
Okay. So, okay, for the revision. Okay, because we have only 8 minutes more, I show you the answer only lah. Okay, and I will share the answer. Okay, because I think a few of you didn't manage to finish all, right? Yes, right or not?
Yes, teacher.
Okay, I just show you all because we have 8 more. Okay.
Teacher, do we need to copy the paragraph in page 155?
153. 153 only.
Okay.
The daily one on it because we have in this exercises. Okay, guys, speed revision. Okay, number 1, living and non-living, which are matter which has mass and occupy space. Okay, state of the conclusion. Okay, guys, as you can see here, air has mass. So I already jot down here.
Teacher.
Teacher,
you are not sharing screen.
Yes. Sorry. You nampak teacher bercakap je. Alright, so sorry. Alright.
Teacher, page 153 is about what?
153 is about the theory, the what? This one. Can see not?
Cannot see.
Cannot see. Right? Stop presenting. Okay, wait. Entire screen already shared. This one, can see not? Oh, sorry, 155. 155 dia. 153 pula.
Okay, teacher.
Okay, thank you, teacher.
Okay, done. Okay, this one. All right, so guys, so please, if the question asks you conclusion, so is the conclusion. If the question asks you observation, please state observation. Again, observation is what we see. So here also, I already give you the answer for the observation lah. Okay, later you check by your own. Okay, class. Okay, we have the blue things here is the air particles. Okay, so the air particles inside the balloon is initially same. But then when we pick out, so what happens? One will have more mass rather than the other because mass is quantity of matter. Maybe this one, the particles are already, okay? Same goes with this one. So this one we already discussed in the Jamboard, all right? So physical properties, observe, okay, when we can measure, so totally become physical. Okay, chemical, okay, as long as another substance, new substance is formed and also involve chemical reaction such as heating and all reaction got evidence the bubbles and all right. Okay, solubility and everything, that one is physical. The one that I highlighted in green is actually is not in your syllabus, okay, but then is the answer also lah. Viscosity is the thickness of the liquid that are resistant to the ability of the substance to flow. Okay, that is not in your syllabus yet. But then guys, oxidation is the any process that involve or required oxygen. Okay, later we will study in chapter 7. Okay, our chemical properties. Okay, keton. Keton, so two things to discuss, small and discrete particle and they are moving, all right? And then this one also, why no marks given here and I write down in green because it is not in your syllabus yet, but you need to understand this for chapter 6. So it's the smallest particle in the basic units of matter. If we study in chapter 2, cell is the basic units of matter and the basic units of cells is atom. Remember, all living things is matter as well. Okay, so draw the arrangement of the particle in the 3 states of matter. So this one will be the answer. And remember, this is how long we have here the arrow. When heated going this way, heat is absorbed. Why heat is absorbed? To overcome the force of attraction between the particles. So I already draw here, down below. Can see or not? Can see or not, guys?
Teacher.
Can teacher.
So this is the force of attraction between particle. We do have two, strong and weak. Usually strongest in the solid state, weak in the liquid state. All right. Okay, and then one mana lagi? Okay, so underline the correct. So this one, okay, particles in gases, okay, gases. Okay, because kinetic energy is the movement. So the movement fastest one is the gases. And then particle in solid lah will have a very strong force of attraction just now. Okay, so how to, okay, this one is the formula lah. Fixed volume, VOL. So you can see here OL possessed by liquid and also solid, and S belongs to solid only. Okay, when we discuss about fixed shape, is actually versus the other two, liquid and gases will follow the shape of the container. When heated, the distance between the particle of substance will be?
Teacher, can I write increase?
Wait, when heated, the distance between the particle of substance will be increase. Can also lah, can.
Teacher, can I write further?
Further apart, can. Okay, when being compressed, the force of attraction become stronger. Okay, nitrogen can be compressed because they are large spaces. Okay, you know, when we compress means, if easily compressed means they have lots of space. For example, as you can see here, gas is easily compressed, right or not? Because due to the space. But meanwhile, okay, this one, all right, for the solid cannot be compressed because they have less space. Okay, very less space. Okay, all right. Okay, this one. Okay, the movement of particle, all right. So, okay, so this one is diffusion lah. Higher concentration, remember, higher to the lower concentration, and the highest one goes to gas state, gas, liquid, solid. So this one, the movement of particle known as Brownian. Okay, I never use, this one is actually green color, okay. Okay, it's okay lah. Okay, so this one is not given, marks not counted. Okay, so diffusion take place very slow in solid. Why? Because the arrangement are very close, okay? Close packed together, most very fast, okay, the big space. Okay, so this one, okay, I already discussed with you all just now. Okay, melting, absorb already. Okay, so this one, okay, I want to make correction. Okay, the one that I think 1 UUM, they use the term for physical properties, reversible. Okay, for example, this one lah. Reversible means that from solid to gas, gas to solid back. Something like that. Okay, for example, when the question asks you, state the change of the states of matter in daily observation. Okay. State the changes of states of matter. Alright, so this one, the change in state, you should mention this one, yeah? Liquid and gas together, this one. Okay? Alright. Okay, and last one, the temperature remain constant. Okay, degree of hotness, the mass constant, constant. Okay, alright, total 47. Okay, guys, I will give you the answer later. Any question?
No, teacher.
Okay, I hope no question for today. Alright, so it's already 5 o'clock. Alright, so with that, I think, okay, see you on next Tuesday. Okay, bye all.
Teacher.
Assalamualaikum. Okay, how many of you? Okay, alright, thank you guys. Okay, bye.
Thank you, teacher.
Okay, bye. Bye everyone.
Thank you, teacher. Bye.
Teacher, bye.
Bye. Okay, bye. Bye everyone.
Thank you, teacher.
Thank you, teacher. Bye.
Okay, bye. Bye everyone.
Thank you, teacher. Bye.
Bye. Bye. Bye everyone. Okay. Okay, bye.
Teacher, the examples of change of state of matter, that one must copy. Teacher.
The example of change. The question,
No, it's in the page 156.
1-5. Oh, the examples. No need, because we have in the exercises.
Okay, teacher.
Or you want to jot down anywhere in the note, in the flip note also can. You just a bit space. You may jot down.
Okay, teacher.
All right. Okay. Okay. Bye. Bye all. Bye everyone. Okay. I will stop the meeting now. Okay. Bye. Bye everyone. Assalamualaikum and bye.